Hello everyone, welcome to Programming Knowledge. I again welcome you all to yet another tutorial at Programming Knowledge. So today's tutorial is going to be very interesting. Let's today solve the problem like if we get an interview problem. So let's do it in a way like let's today do it this problem. We are going to solve this problem, that is counting bits, and like I'll tell you all the approaches how we can solve this and how we like if we get this problem in an interview. So let's add this as an interview question and interview question since let's do it in a way like if I get this question in an interview, so how we can solve this program from a naive approach to dynamic programming. So we will not directly tell like we will not directly tell what is the optimal approach in the starting. First, we will start with how we can solve this problem using the name approach, then some little optimal approach, then more efficient approach. So let's solve today's problem using an interview question. So I'll copy this and sorry, yeah. So let's solve today's problem using an interview problem style. So like we have a live editor here. So interview question says for I is equal to 0 to n, return a list of number of ones in binary representation of I. Okay, I'll explain. Like we have an input 5. Like binary number of ones in the binary representation of 0 is 0. Number of ones in binary representation of 1 is 1. Number of binary representation. Okay, I'll explain this. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. So these are the binary representation. This is for 0 and number of like this is for 0 and number of ones in this binary representation is 0. Number of ones in the binary representation of 1 is 1. Number of ones in binary representation of 2. So this is a binary representation of 2. This is 1. This is 2. This is 1. This is we are going to solve this problem in an interview style, and this is 2. So this is a 0 in decimal. So let's do the one thing, 0, and this is 1, and this is 2, perfectly fine. This is 3, and this is 4, and this is 5. So here you can see we are going to solve this problem using interview style. This is perfectly fine. So we need to return. Okay, first what we will do, the native approach. Define approach 1. Let's define solve this using approach 1. I have n, so I have a result array, and I would return this result. Perfectly fine. Now this is first approach 1. For I in range n, binary representation. Binary representation is equal to bin of I, and we are going to slice this index with 2 because there is an 0 comma b in 0 b in the beginning. And what I'll do, result dot append binary dot count 1, and then we are going to return result. So let's take n is equal to 5 and print approach 1 of n. Perfectly fine, and let's run this program. Yeah, so we have an array of 0, 1, 1, 2, 1. So does this match our expected output? 0, 1, 1, 2, 1, 2. Okay, we need to run this loop for one more time since we are using this. So yes, 0, 1, 1, 2, 1, 2 is our answer. So it matches perfectly fine. I'll copy this test case here as well. So yeah, so I've already copied, sorry. So 0, 1, 1, 2, 1, 2 is our answer, and we get. So time complexity of this approach is time complexity time complexity of this approach is big O of n square. Since we loop using O of n time and count functions also take O of n, so O of n square. Let's solve this using approach 2. define. So approach to n. So we will define one another function, count one, count one. See, define count ones, and this is also known as Hamming weight. So this is also known as Hamming weight, and you can solve this like the Hamming weight. Define Hamming weight, or you can give any function. I can define count one. So this implementation takes log and time. So what you can do, while define count one of like x, you can take this as x, while x is equal to x and x of x minus 1 bitwise, and you do count plus is equal to 1, and you take count is equal to 0, and in the end you return the count. Perfectly fine. And you can either what you can do, this would create a confusion. So what you can do, yes, you can, yes, perfectly fine. So define approach 2, I'll have a result array, I would return the result array, return result. And now for I in range n plus 1, result dot append, I would append count 1 of I, and this approach would take time complexity of n log n. Now I'll break this down. Why n for loop start log n for count 1. So is equal to n star log n is equal to n log n. Okay, and I would explain the same using this n for loop, and for n for dot count, and this would give me n star n, and this would be n square. So just a quick review, that n4 is for loop, n for dot count, and so n for dot count, and it gives you n into n is equal to n square, and this is n for loop, and log n for count 1, and n star log n is equal to n log n. So let's do print approach 2 of n. Yes, the answer matches. Now we'll give another approach using dynamic programming. Define. So we are going to solve this using an interview style problem, so that you are not supposed to tell the optimal solution in the very first beginning. So time complexity of this solution. Okay, give me a second. Yes. Time complexity of this solution would be a big O of n only, and that is for loop only. Okay. So we have a result array, result is equal to, and we are going to return the result. Perfectly fine. And we are going to do print approach 3, print approach 3 of n. Okay, now how we are going to solve this? So we are going to solve this using dynamic programming. Very easy formula, nothing much. What you need to do, the result, either you can result is equal to 0, since you initialize the base case. For I in range 1 comma n plus 1, you don't start the I for 0, because you have already initialized here. What you need to do, result dot append, simple formula, result of I by 2, and what you need to do, result of I by 2 plus I modulus 2. This is a formula using dynamic programming we make, and simply run this and you get the same out in all the three cases. But the difference was of time complexity. First we solve using the n square approach, then we solve using n log n approach, then we optimally find the O of n complexity using dynamic programming, and this is how you solve the problem in an interview. So thank you guys. You can have a look again. N square solution, then n log n solution, and then n O of n solution. So you solve the problem in an interview. So this was a bonus. So like a very good how you solve the problem in an interview. So thank you guys. Thank you so much. The motive of the problem was to get all the number ones in the binary representation of I for I is equal to 0 to n. So perfectly fine. Thank you guys. Thank you so much. I'll catch you in the next tutorial. Thank you guys.